More than 1,200,000,000 fashion items are produced annually from wool, a material that has held its place in the industry for centuries. At first glance, it seems simple, but in reality, it involves a complex technical chain. But what makes this fiber so enduring? The explanation lies hidden beneath the surface. It is found in a precise sequence of transformation. Behind every sweater, scarf, or heavy coat exists a rigorous process. The wool is sheared, washed, carded, spun, and finally woven into fabric. It is visible how human craftsmanship and modern technology refine the raw gift of nature with every step. But this is just the beginning. From windswept pastures to factories operating day and night, the workflow remains constant. One can notice the unceasing rhythm as wool turns the ordinary into a material that sustains the global fashion industry. The cycle moves to the next stage. Over 4,400,000,000 pounds of wool are harvested every year from vast pastures. Why does this material remain a cornerstone of the global textile industry? At first glance, synthetics seem to dominate, but in reality, wool remains a pillar of sustainable fashion and a link between nature and technology. One can notice how the raw material originates on farms covering thousands of acres. But this is just the beginning. 3 nations, Australia, China, and New Zealand, together supply more than 60% of the world's total output. Australia leads in fine, high-quality wool production, while China acts as the largest processor and consumer. It is visible how fiber enters lines to become sweaters, scarves, and upholstery fabrics. Therefore, the economic value exceeds $80 billion annually, including raw exports and finished high-performance insulation materials. The camera glides over bales of fiber moving toward processing centers for distribution. Everything only gets more complicated as the scale increases. This renewable natural fiber continues a story thousands of years in the making. Thousands of acres of open pastures in New Zealand and Australia form the foundation of the wool industry. Farmers manage flocks here under strict standards to ensure the cleanest and most consistent fleece. Each farm carefully selects breeds according to specific production goals. Merino sheep provide ultra-fine fibers, while Romney or Corriedale breeds offer strands that are longer, stronger, and easier to weave. But this is just the beginning of the biological management. Why is every sheep tagged and recorded with such meticulous detail? This comprehensive data on age and health ensures that only the most productive genetic lines are maintained. At first glance, grazing seems like a natural and chaotic process, but in reality, it is strictly rotational to keep the soil fertile. This prevents overgrazing and preserves the land. One can notice how the flocks are moved to fresh sectors while previous pastures recover. Farmers supplement the animals' diet with hay, grains, and minerals to promote thick, uniform, and bright wool growth. Barns remain dry and well ventilated to prevent parasites and skin disease. Each season, workers vaccinate, deworm, and inspect every animal. Because the sheep's health directly determines the fiber's quality, it gets more complex further on. Before breeding season, ewes undergo a specialized process known as flushing. Their diet is enriched for several weeks to boost fertility and produce stronger lambs with finer wool. During lambing, mothers are kept under close supervision to ensure that newborns nurse promptly. After a few weeks, the young are tagged, weighed, and moved to lush pastures for weaning. It does not end at this stage. When the warmer months arrive, the flocks are washed and treated for ticks. They are left to dry naturally before shearing begins. Each sheep is handled gently to avoid stress, ensuring a single, clean, unbroken fleece. One can see how the wool remains intact during the handling. After shearing, the animals are checked again, treated for minor cuts, and allowed to rest before returning to the fields. Every stage from nutrition to care follows strict animal welfare standards. Only healthy sheep can produce wool that is pure, durable, and of the highest value. The raw material is now ready for collection. 250 sheep per day? Exactly this number passes through the hands of a professional shearer during the peak of the season. Why does the process strictly coincide with the arrival of warm weather? It might seem that the fleece could be harvested at any time after months of care. However, this specific timing ensures the animals stay cool in the summer and allows the wool enough time to regrow before the winter cold. Before the operation begins, the flock waits in clean, dry pens. Farmers deliberately feed them lighter portions to maintain a steady state during handling. But this is just the beginning. The electric clippers activate with a steady hum, armed with fine blades for precision work. One can notice how the operator moves in a specific sequence, starting from the belly and legs before continuing to the sides, shoulders, and back. The goal is to remove the entire fleece in one smooth, continuous motion without damaging the fibers. An experienced specialist completes the task in just 1 to 2 minutes. At first glance, it looks like a routine haircut, but in reality, it is a complex manipulation requiring years of training. Because the textile industry demands perfection, short and dirty wool from the belly and legs is instantly separated for lower-grade products. Only the long, fine white fleece from the back and sides is reserved for high-end textile manufacturing. After the procedure, the sheep are checked for cuts, treated with antiseptic, and sent to wind-sheltered enclosures to rest. The fleece, the result of a full year of growth, becomes the primary raw material. It gets more complex further on. The camera glides over wide tables where each fleece is laid flat for manual inspection. Therefore, skilled graders examine every inch for color, fiber length, and fineness. They remove sections tangled with dry grass or dirt, while wool too short for spinning is discarded. Graders separate the raw material by region: belly wool for industrial use and back fibers for fine textiles. This meticulous stage maximizes the value of every unit and ensures consistency across production lots. The process is only gaining momentum, but loose wool cannot be transported efficiently, so clean fleeces gather in the baling area. Powerful hydraulic presses squeeze each batch into dense rectangular bales, weighing between 300 and 400 pounds. Workers wrap them tightly in burlap or heavy plastic to prevent moisture ingress. Each bale is tagged with data on the farm of origin, sheep breed, and grade to guarantee traceability. Specialized trucks carry the massive white bales to scouring plants, where the journey of washing and purification begins. 170 to 180 degrees Fahrenheit is the precise temperature range required to strip raw wool of its natural oils. Before the material enters the liquid treatment, wool bales are unpacked at the raw material processing area and spread evenly onto conveyor belts for cleaning. Why does the process begin with aggressive mechanical separation instead of immediate washing? It seems logical to soak the dirty wool right away to dissolve the dirt, but without the opener machine, the tangled fibers would not absorb water effectively during the scouring stage, leaving impurities trapped inside. Multiple rows of high-speed rotating metal teeth tear through the clumps to separate fibers and vigorously remove embedded impurities like dust, grass, and soil. One can notice how the loosened wool becomes fluffy and porous, preparing it for better water absorption in the washing stage that follows. But this is just the beginning of the cleaning cycle. The scouring system consists of 6 continuous hot water tanks, where the material is submerged. The first 3 containers hold a diluted soap solution designed to dissolve lanolin, the natural grease secreted by sheep that protects their fleece from moisture. The remaining 3 tanks are filled with clean water for thorough rinsing, ensuring no chemical residue remains on the fibers. At first glance, the washing line seems like a simple flow of liquid, but in reality, it is a strictly controlled environment. Water is filtered and recirculated in reverse flow through automated pumps, saving energy and maintaining consistent quality across batches. Between each tank, soft press rollers gently squeeze out dirty water with steady pressure without damaging the delicate fibers. Temperature and flow sensors automatically adjust the wash parameters to prevent overheating or overflow, keeping the system at optimal safety levels. It does not end at this stage. The extracted lanolin is collected and refined separately for use in cosmetics and pharmaceuticals. The process then moves to the removal of moisture. Finally, the clean wool enters a rotary drum dryer where warm air circulates evenly. The drums rotate continuously, allowing the heat to penetrate every strand to remove excess liquid. One can notice the steam rising as the fibers dry inside the chamber. When the process is complete, the fibers reach a standard moisture level of about 12%. They emerge soft, bright, and completely free of impurities, ready for storage and quality inspection. Inside the material conditioning facility, dried wool bales are fed into a fiber blending machine. Each batch, differing in color, fineness, or origin, is precisely weighed to ensure exact proportions. Rotating rollers with spiral blades separate fibers clumped during drying, mixing them thoroughly. A fine mist system keeps the air humid and static-free, while sensors control the speed for perfect uniformity. Transition to the next level involves structural alignment. The fibers emerge soft, light, and elastic, ready for the next mechanical stage known as carding. The material passes through the carding machine, equipped with multiple metal tooth rollers spinning at different speeds. This creates controlled friction and pulling force to separate, straighten, and gradually refine the tangled mass. Throughout the process, dust extraction systems and electronic sensors remove short fibers, fine dust, and impurities left from previous cleaning stages. As the material exits the chamber, it emerges as a thin, continuous web of fibers. It is visible how the machine automatically rolls this web into soft slivers of consistent thickness and weight. Carding restores the wool's natural structure and enhances the cohesion between fibers, a critical factor determining the smoothness and durability of the final textile. However, in many small-scale workshops or traditional handcraft studios, artisans still preserve the ancient art of hand carding using metal combs. Two brush-like paddles covered in fine steel teeth are interlocked and pulled apart repeatedly, a motion performed dozens of times until every fiber lies perfectly parallel. Though time-consuming, this manual technique allows for delicate control of tension and pressure, preserving the wool's natural elasticity, sheen, and texture in ways that machines can hardly represent. Thus, the processed material is fully prepared for the subsequent steps of textile creation. Multiple rollers rotate at slightly different speeds, creating the precise tension needed to transform loose fibers into thread. This occurs in the spinning section, the critical phase that determines the strength and fineness of the material. Once the combing stage is completed, the long and refined wool slivers are transferred to the multi-roller spinning frame where the mechanics of drafting begin. Why is the speed of every roller strictly differentiated? It might seem that the wool simply passes through the machine in a straight line. However, the front rollers hold the fibers steady, while the rear rollers accelerate slightly. This calculated action draws the sliver thinner while maintaining its elasticity and internal cohesion. It seems like a simple mechanical pull, but in reality, invisible forces like static electricity caused by continuous movement threaten the fiber. Therefore, before the twisting unit, the surface of each strand is coated with an ultra-thin layer of spinning oil. One can notice how the fluid reduces friction and prevents buildup. But this is just the beginning. As the fibers pass through the central twisting assembly, they are tightly bound together into a unified strand. The camera follows the thread as tension sensors monitor the degree of twist to ensure perfect consistency along the entire length. This forming structure is both strong and resilient. Next, the finished yarns are wound onto large bobbins and later rewound into smaller spools of standardized size. One can observe optical scanners inspecting each strand in real time, detecting thick spots, weak points, or over-twisted sections. Everything only gets more complicated. Any discovered flaws are automatically trimmed and rejoined using heat fusion. This technology produces smooth, seamless joints, nearly invisible to the naked eye. In contrast, smaller workshops still preserve the heritage of hand spinning with a spinning wheel, where artisans rely on tactile control to adjust the twist intuitively. This slow and deliberate method yields yarns with a distinct organic character in texture in ways that machines can hardly replicate, often reserved for high-end handcrafted products. The final yarn emerges with exceptional tensile strength, smooth texture, elasticity, and structural integrity, the result of precise engineering combined with generations of craftsmanship. Thousands of individual wool strands are threaded through needles and heddles to form the structural foundation of the future fabric. The yarns, having achieved the ideal balance of fineness and strength, enter the weaving system to transform from loose threads into a unified structure. Automated sensors measure the tension, humidity, and density of the material before the process begins. This ensures stable operation throughout the entire weaving cycle. But this is just the beginning, because even the slightest deviation in a single strand can disrupt the intended pattern of the weave. Why is such rigorous monitoring required before the loom starts? The sensors work continuously to prevent structural failure. Without this data, the high-speed mechanics could snap the refined yarns, ruining the textile's integrity. One can notice how the reed compacts the weft threads firmly, locking them tightly with the warp after interlacing by a shuttle or air-jet system. At first glance, the loom operates with chaotic speed, but in reality, every movement is monitored by fault detection sensors. If a broken yarn, loose tension, or sequence error occurs, the machine halts instantly. It gets more complex further on. Therefore, operators must step in to correct the issue before the mechanical rhythm resumes. When the fabric reaches its standard length, it is wound onto a take-up beam and moved to the inspection area. Strong, bright lamps illuminate the textile to reveal imperfections. Minor flaws, such as knots, dark specks, or uneven tension, are corrected by hand. It is visible how the woven wool fabric has finally achieved a solid structure and uniform surface. The material is now ready to serve as the essential foundation for the finishing treatments that will follow in the mill. Two distinct transformations occur as the raw wool fabric enters the finishing department to stabilize its structure. The material is immediately subjected to the fulling process. Why immerse the textile in warm water with constant agitation? It would seem that simple washing is sufficient to clean the cloth, but this specific mechanical action forces the wool fibers to interlock naturally, effectively increasing the thickness and thermal insulation of the canvas. And this is not the limit. The density of the fabric rises significantly. It seems simple to smooth the surface, but in reality, fine carding rollers equipped with delicate metal pins remove loose fibers with high precision. One can notice how the texture becomes uniform under the mechanical action. Certain batches are then dyed according to strict design specifications. Steam sets both the color and the dimensions of the cloth before the final drying phase. Engineers maintain a controlled low temperature to preserve the natural luster and elasticity of the fibers. The once rough textile turns into a smooth, resilient material, ready for tailored coats or luxurious blankets. However, the process does not end at this stage. The finished fabric moves to the cutting section inside a climate-controlled room. Humidity and temperature stabilize the material before the blade touches it. Automated rotary blades follow digital templates to ensure perfectly smooth edges on every curve. One can observe how the machine cuts without deviation. Each piece is numbered and transferred to sewing stations, where double needle machines assemble collars and sleeves. Steady steam presses work alongside the operators to preserve the shape of the hems. Finally, the garment is inspected, folded, and sealed for global distribution. Wool completes its long journey, ready for the modern wardrobe. Two distinct worlds collide to produce a single, durable material. From the vast open pastures to the precision of modern textile mills, the wool undergoes a complete metamorphosis. Why is this delicate balance critical? It seems nature finishes its work on the sheep. But without technology, the raw fiber would remain unusable. Human ingenuity bridges this gap. At first glance, the machines seem cold, but in reality, they preserve the fleece's natural warmth. One can notice the final texture emerging. And this is not the limit. The material stands as a testament to industrial craftsmanship.